Guys, A04 is going to have us implement another function for our little framework, and this function is going to compute the greater common divisor value of two positive integers. So we are going to have to follow the same guideline than before. Okay, this is what we are going to have to do to update our 4 files which make our application. So prototype in tools.h, implementation in tools.c, then use it from main.c and use it from test.c. We still have the same type of error checking. Okay, what changes, of course, is the intent of the function, what we are going to compute. We are going to compute this time the GCD instead of the LCM. So let's start by briefly trying to design our code, our algorithm. Okay, so I'm going to start with concrete examples. For example, one of the test cases is 9 and 3. What is the GCD of 9 and 3? Well, the GCD of 9 and 3 is going to be computed by first taking the modulo of the first argument with the second. So we are looking for the greatest common divisor. So we start with the number themselves and we are going to run down. In our case, 9 modulo 3 is 0. 3 goes 3 times and the remainder is 0. So because the remainder is 0, we don't have to go any further. So GCD is equal to 3. Okay, we found our solution. Now, what about if we have a situation that is a little less trivial? For example, I'm trying to compute just GCD of, well, let me take 9 and 5. So it's less trivial because 9 doesn't divide 5, 5 doesn't divide 9, right? Well, my first step is still the same. I start by doing 9 modulo 5. What is 9 modulo 5 in this example? It's 4. Okay. Now, what I have achieved is I know that first I didn't reach yet my GCD, which is going to be really useful when I do my recursive version. Okay, I know that because this is not 0, I didn't reach yet the value of my GCD, and I'm going to keep searching for it. But this time I'm going to take 5, okay, and I'm going to take the remainder of 9 modulo 5 as second parameter, and I'm going to look for a GCD between those two guys. How am I going to do that? 5 modulo 4. 5 modulo 4 is 1. Still different than 0, I didn't find yet my GCD. So I'm going to keep calling GCD 4, and then my new value 1. GCD 4, 1, 4 modulo 1. Well, it goes 4 times, remainder is 0. Bingo, I have my GCD. It just so happened that my GCD is 1, which is a default value when you cannot find another GCD between two numbers. So just running those two examples has been really helpful for me to try to kind of sketch out an informal algorithm. So now that we have this as a guideline, we can move on to the code and we can try to implement something. Here is tools.c. We are going to implement our GCD functions pretty much the same way we implemented the LCM one. By the same way, I mean we are going to have error detection at the beginning, and then we are going to dig into the main loop, which does actually the job we are supposed to achieve. So here we go. Int n equal 1. That's not quite going to work like that, but I still need an extra parameter, an extra variable to just store temporarily the modulo of a by b. So I'm going to keep a variable n around. If a less than 0, b less than 0, return -1, that's still good. We still behave the same way. Now, instead of this loop here, what I would like to do is I would like to keep doing my modulo operation, okay, until I reach suitable result. So I'm going to remove my for loop. It's not a simple counting operation. Instead, I'm going to do a do while loop. And I'm going to set right now my loop to be infinite and see what I'm going to do inside. Maybe I will end up setting a condition. Maybe I will just end up exiting the loop whenever I meet a satisfactory condition from reading the loop itself. So do while, what do I need to do? Well, the first thing I need to do is to compute this modulo. So n equal a modulo b. If n is null, then I found my GCD. Okay, so if n equals 0, I'm going to return my GCD. What was my GCD? Well, let's have a look back to what we did here. When A modulo B is null, B was my GCD. Okay, so I can here go and say return B. Else, what happened if I didn't return anything? Well, I'm still looking for my GCD. So what happens is that my value for A becomes the value of B, and my value for B becomes the value of N. I keep shifting like that, okay? And I'm going to try now to compute again the GCD between A and B, but the value of A and B have changed. Now, watch out for one thing. Let's make sure that you didn't miss anything about parameters by value and by reference. A and B are parameters of the function, and I need to rename it, I just realized that, of the function GCD. This means that they exist on the stack in each activation record of the function GCD, which means when the main calls GCD with value of x and y will not be modified because I assign new value to A and B. I'm just playing with my local copies of the parameter here. Let's try to save, and let's see how right or wrong we are on this one. So I have the GCD function. I'm going to first do a little compilation just for the sake of checking the syntax, and I'm going to compile with main.c. Okay, syntax is okay. Now, let me go into main.c, and I'm going to call the GCD function when option 3 has been selected. Let me start with a bold cut and paste here. We're going to use the same template, okay? Result is going to be calling GCD on x and y. If result is -1, then there was a problem indeed. GCD. Else, I'm going to display what was returned to me by the GCD function. And that should be doing it for the main.c. So without further ado, I'm going to test this code. Compile implicit declaration of function GCD. Oh well, I forgot one thing here. I forgot my tools.h, and I forgot to insert the prototype of GCD. Int A, int B, and we are good. Save. Let's compile again. GCC tools.c main.c. Compilation is successful now. Let's try to run this code. X is 0 and y is 0. Well, let's change that for a starter, okay, so that I have something non-trivial to test with. What about 9 and 3? And then compute the GCD with option 3. Current values 9 and 3. GCD of 9 and 3 is equal to 3. That makes sense. Now let's try. I should not be testing really my application, my function yet, but let's go for it real quick. What if I try 9 and 5? There's a GCD of 9 and 5. Let me see, where is it? Sorry, I just said the value. Oops. Option 3. GCD of 9 and 5 is 1. Okay, looks like it's working so far. So I would have to test negative values, etc. Instead of spending a lot of time doing those tests, I'm going to exit my application and I will incorporate those tests in test.c. So let's go to test.c. My main is getting long here. It's actually getting too long for my test because I have here everything to test LCM, and I'm going to patch after that everything to test GCD. So instead of doing that, what I would like to do is improve a little the readability of my code by grouping everything here in a single function. And this function is going to be void test underscore LCM. Takes no parameters, and everything I did here to test LCM would be right here. Now, I could do things even a little better than that. What about it? I have here x, y, and result. Okay, well, what I could do is I could try to replace all of those cut and paste codes by a call to a function. Let's call it test LCM. I'm going to call it one case. Okay, test LCM case. So we have here now a function to which I can pass 10, 20, and the expected outcome. And I would like it to do exactly this job. So let me take this code here, and I'm going to have void test LCM case here, taking as parameter a value x, a value y, and a value which I'm going to call expected. And inside this function, of course, I'm going to have the code that I had for one test case here. Well, I don't need to assign x, y, and result anymore. This is going to be done when I receive my parameter. All I need to do is compare, and I renamed it because the name result was kind of ambiguous. Is it the result of calling the function, or is it the expected result? Well, now it's clear. I'm going to call LCM xy, and I'm going to improve a little my code by having a variable observed result, which is going to be assign the result of calling LCM on x and y. And I'm going to then compare my expected result to my observed result. And if this is not, the result is not what I expected, I'm going to display here the observed result. I'm going to display after it what was expected. And I'm going to refine a little my display here. I'm going to say, for example, \t equal the value \t different than the expected value. So that's going to allow me to simplify a lot my code, and this is going to allow me to make it also a lot more readable. So test LCM case free, and of course I'm going to have to retest that, okay? And expected will be 9, so let's get me rid of all that code. Then test LCM case 5, 9, 45, and I'm going to use the same type of framework when I'm testing, of course, GCD. Test LCM case -1, 3, -1. Test LCM case 3, -1, -1. Test LCM case -9, -30, -1. It would be a bad idea for me to change the test case right now. Change one thing at a time, okay? You change your implementation, don't change the behavior, and vice versa. So there we go. And I don't need even those little variables here. So I have all of my test case, and I have all my cases here. So let's save. And before we move on to testing GCD, I really need here to recompile to make sure I don't have any syntax error. And since we didn't modify main.c, we can just directly recompile test.c, and I'm going to run it to make sure that it's still behaving the same way. No errors detected. That's fine. I'm going back to test.c, and now we need to develop some cases. Well, actually, it's fine, but it's fine also because I didn't call the function from here. So let's call test LCM from the main and make a decent test, actually. Something that's going to mean something, actually. Okay, there we go. All right, I introduced a couple of problems here with tools.c and test.c. So let's see. Implicit declaration of test LCM, that's normal. This is because I call it before to define it. So I'm going to go ahead and put the prototypes here so that I can still have my main, it's a personal choice, on top of the file, at the beginning of the file, okay? So test LCM is here. Why not? I'm going to put test LCM case as well, so that I can, it's just a matter of visibility here, or code style, if you will. I'm going to organize my file so that the main can use any of the test functions. The test function then come next, and then the test function for each single case, the generic test function here, comes after that. So I have test LCM case. I call test LCM here from the main, as saved, and we're going to recompile and test to make sure it's working. So GCC, sounds good to me right now, a.out, all the tests were successful. So now we have something that is a little bit functional, a little bit more functional. You will notice how I could have deduced that my tests were successful easily, just by running it and having no display on the screen. Well, this was hiding the fact that I forgot to call test LCM. This kind of stuff can be detected easily by just going to your LCM function here and returning a value, an arbitrary value like 42, for example. You save your file, you go back to Conqueror, and once your file is saved, you compile, execute, and this is going to show you that indeed your tests are running when the function doesn't mean anything. Just make sure you do not forget afterward to remove that return 42 so that you are back in a version of the code that actually does something meaningful. Okay, so this part is done. Now that we are going to reorganize our code, we proceeded with a little refactoring, if you will. We are going to write the function to test our GCD code. Void test GCD. And now what we need to do is we need to do pretty much the same job that was done with the LCM, except that we're going to do it, of course, with different values. So I'm going to have a test GCD case, and I'm going to refer back to my assignment description. What are the different cases I have? I have, well, let's use those as a starter, okay? 2010, which should return 10. So 2010 should return 10. And I'm going to cut and paste. I'm going to cut and paste this call because I'm going to just modify the parameters. So what's coming next? 9.3, we should return 3. 9. No delay here, where am I? There we go. 9.3 should return 3. And then let's keep on going. 3.9 should return 3. 6.9 should return 3. 3.9 should return, where is it? 3.9 should return 3. 6.9 should return 3. So let's go back to the code once again. 3.9. So we are reverting the order here, which takes care of pretty much a lot of the effort I was expecting from you as far as designing the test case. So over test case would give you more freedom for you to design. 3.9 return 3. 6.9 returns 3. And then 5.9 and then holds the negative. So 5.9 should return 1, so that's one test that is going to cover the cases where we don't have an obvious GCD. Okay, 5.9 should return 1. And then we can test the negative possibility. So instead of doing just what is requested of me in the assignment, I'm going to try to think it through a little more. 3 and 1 minus 1. Okay, we did already those test cases in our previous, well actually, if we did them already, why am I bothering even like redoing them like this? Let's go here. And we have already test cases that test that 1 or 2 negative number are going to be tested. So I'm going to reuse those calls. And instead of LCM, of course, I'm going to have GCD. So far I've been calling this phantom function because it's not yet implemented, okay? I'm going to take these, cut and paste them, and give us some prototypes for GCD, the complete test function, and the case-by-case test function. Of course, what I need now is to implement, you guessed it, I need to implement void test GCD case. Same thing, x, y to arbitrary value, int expected. And in fact, this is going to be really close to the code I have here. So why not start by borrowing it? There we go. We have our observed result will be the result of calling GCD. And once we we work with pointers in the second part of this course, we'll be able to make a better test function here, a more generic one. Okay, but for now we don't have pointers and functions, so we have to rewrite the code here. So GCD, there we go, observed, expected, and let's give it a spin. Go back to the Concur window. Start by weeding out all the compilation errors. Seems like there was not that many of them. Run a.out. No output. Well, that's not enough to guarantee us that everything is working, right? So let's go back to test.c. Make sure that everything is called. I call test GCD. Alright. Test GCD is going to call GCD on all those cases. And then let's have a look again at those cases. They correspond to the list we have. Let's have a look finally to our code. Make sure we didn't forget anything. If these are negatives, okay. Well, this is pretty much where we can call it a stop here.